Hello guys, this video is for Algebra 2, Week 7, Thursday and Friday, but I'm going to go over Thursday first. And we are dealing with half-life. Okay, so before I get into what half-life is, let's talk about what's exponential growth and decay. So we have growth and decay. So when we talk about growth, we are still talking about the same formula as that a times b to the x power, but like the first number doesn't really matter. So I can use like any number. So I'm not going to put anything there because it can be any number, okay? But then the b part, raise it to the x power. That part really matters. If we are talking about growth, that means we want to see a number that keeps on increasing and increasing, okay? So that number must be bigger than 1. Okay, so for example, it can be like a 5 in here, or it can be like 5 over 2 to the x power, because 5 over 2 is really 2.5, right? So any of these numbers are okay. And in terms of your graph, you would see a number that's going to slowly increasing like this. So it kind of looks like a J, or half of a parabola, right? So what about decayed? If I'm talking about decay, that means, again, the front number doesn't really matter, but what's the number that we keep on multiplying that's matter. So decay means your graph is going to keep on decreasing, but we're not going to have this positives and negative, type of graph. Like we're not going to go alternating positives and negative. We want a number that's within, must be between, in between 0 and 1. Okay, so most of the time you would probably see fractions here or decimals, but 0 point something, or let's say 1 over 3 or 0.4. Okay, these numbers, you're taking a portion of your original. You keep on taking a portion of the original, so that's why the graph decreases. So this side of the graph would go from, let's say here, go down, down, and it will slowly go down, but again, it won't pass through the x-axis because we're never going to reach to 0. We keep on taking a portion of something, so it will never reach to 0. Okay, so that's what growth and decay is. I just kind of want you guys to understand the difference between the two to get into half-life. So half-life, right here, half-life is the amount of time it takes a substance to decay to half of its original amount. Okay, so let's talk about an example. Simeon is studying for a big test and is trying to stay awake. He drank a 12-ounce can of Big Buzz energy drink that contains 80 milligrams of caffeine. He is wondering how long the caffeine will stay in his system if the caffeine has a half-life of 5 hours. Okay, so first off, we're given like 3 numbers here. A 12-ounce can. If we look at this chart right here at the bottom, they talk about the time elapsed and the caffeine and the number of half-life cycle. We didn't really talk about the ounce, like how big this bottle is, so we are not gonna need this 12 ounce. Okay, but this 80 milligram is very important because before anything, like once he, like intake this 80 milligram of caffeine, at 0 hour, he has 80 gram in his stomach. 80 milligrams, sorry, 80 milligrams of caffeine in his stomach. And that's considered a 0 cycle first. We haven't gone through the half-life yet, okay? But after 1 cycle, that means after 5 hours, how much caffeine would he have left in his body? If the half-life is 5 hours, that means we're going to take half of this 80 milligram, which is only going to be 40. Okay, because let's pretend if this is a full circle, we only want half of this. So that means the pink is what's left. Okay, actually, yeah, I guess pink is what's left. The other part, it kind of already digested, went away. Okay, and then after another cycle, which is the second cycle, how much caffeine would he have left? After another 5 hours. We would take half of this. Let's see if it will overlap. So half of this part now would be 20. Okay, next cycle, we're only going to take half of that one now. So we are now left with 10. Okay, again, fourth cycle, we're only going to take half of this. So we are now left with 5. Okay, so that's how the cycle goes. And technically, this caffeine is never going to leave his body because we're always going to be taking half and half and half of it. Okay, so let's talk about a formula. How do we come up with a formula to figure out what if we want to check on after 40 hours, how much is left? Or what if after like 100 hours, how much is left? Okay, there should be a formula there. And this is very similar to our previous or even our formula that's up there. Okay, I'm going to write the formula for half-life first. So half-life formula is A equals, A is what you want left, A sub 0 times 1/2 to the T over H. Okay, because we have to put a fraction at the top because if it's 1 hour, after 1 hour, nothing really happens. Like he still has the majority of the caffeine in his stomach, but then if it's after 5 hours, and then this is 5, that means the full half life cycle can do half of the 80 milligram. Does that make sense? So we have to have a fraction up here to kind of break it down every 5 hours. Okay, so let me point to this. T stands for time, and H is half-life. Okay, A sub 0 is the initial amount, and this last one, A, is the leftover amount. Okay, so back to our question. Let me highlight this. So back to our question here, if I want to find 40, that means we gotta substitute. Well, we don't know what our A is here, but we know our initial amount is 80 milligram times 1/2 to the half-life, which is the bottom part of this fraction, is a 5. It says right here. Okay, and then the top number would be 40. And then we have 80 times 1/2, 40 over 5 is 8. And right there, we know that the number of half-life cycle would be 8 right here. Okay, but how much caffeine is really left in the system would be 5 over 16 if you put it in your calculator, which is 0.3125. Okay, I'll show you guys one more time how to put it in the calculator. Let me see. So let's do 80 times 1/2 to the 8, 0.3125. Okay, so back over here, we just need to fill in our answer. That's it. Okay, so let me show you another example, and it can be from one of your homework questions. So your homework for day 4, Thursday, is these ones right here. They give you quite a lot of information, and then you just gotta figure out what the formula is, and let me see, did they ask for formula? Yeah, write the exponential function, and also use the function to complete each table. Let me do number 3. Yeah, I'll do number 3 right here. Let's write it down here. So number 3, you are given 0, 14, 21, 28, 42, and 56. Okay, and it tells you that from 0 to 1, that's one cycle, right? That means from 0 to 14 is one cycle. So 14 right here is your half-life. Okay, so you always want to look out from 0 to 1. What's that number in years has gone by already? Okay, and in our case, it's 14. So let's write down some important information. Half-life is 14. What is our initial amount? Our initial amount starts from 0, so which is 16. And T is 21. Okay, that's for later use. So let's write our formula first. Let's start off with, they using f of n? Oh, a of t. So a of t equals, initial amount is 16 times half-life, half, to the t over 14. Okay, because t, I can substitute any number in there and I'll figure out my the grams and the number of cycles. Okay, so now I'm going to substitute 21, 16 times 1/2 to the 21 over 14. Okay, remember this part right here tells us what cycle this is. If it's a perfect number, like if I put 28 instead of 21, it will give me 2, which is right there. But I know 21 doesn't go into 14 perfectly, and we can write it, you can write it like a, simplify it, or we can write it like a decimal, which is 1.5. Okay, so right here, this is 1.5. It has only gone through 1.5 cycle. So let's finish it. If you put all of that in your calculator, you put 16 times 1/2 to the 1.5 in the calculator, we get 16 times 1 over 2 to the 1.5, which is 5.657. 5.657, and I can write that back in here. Okay, when you guys work on your homework, you do not need to create this whole entire chart again, unless you really want to, but you have to show me the work, definitely, and you can just write down your answers from there. Okay, so that's it for, oh, actually, no, not yet. This is only for day 4. Let's go into day 5. So day 5 is compound interest. This is actually another section already. They talk about compound interest and something called compounded continuously. So I'm only going to go over one of them first, which is another formula. So you kind of have to use your notes on the side while you're working on your homework. Okay, so our formula for compound interest is A equals to P times 1 plus R over K to the KT. Okay, let me kind of talk about why do we need a formula to find interest. So if you, I don't know if you guys have ever been to like open up a bank account, but sometimes they would ask you to open a saving account, right? So if you have a saving account, they would kind of tell you that, oh, if you put in a certain amount of money, we can help you like kind of save it, but give you interest. So instead of, getting, if you put in like $10,000, maybe after a year you get like $5 or something like that. Okay. So, but bank wise now, I think it's so much less. Like you probably can't get $5 even from that. So this first amount of money, P, is your initial amount. What you're investing into whatever you're doing. Okay. It can be your house, or even it can be like something that you're trying to pay for, I guess, and then you can see how much interest you are paying on top of that. Okay, so R stands for rate. That's usually in percentage. And then K at the bottom is number of compounding period. And I'll talk about that in a bit, per year. And then K, again, it's the same K. I'm going to arrow it the same. And T right here is just time in years. And A right here is your total amount. Okay, so the use of this K is that, like, let's say, again, earlier I said in your investing money, K is like a period where these interests actually count. So sometimes it can be compounded yearly. That means you only need to pay for these interests once a year. And then if they are doing this monthly, then they're breaking it into 12 months. And then if they're doing it by like quarterly, then it would be by quarter, which is 4. Okay, so we'll talk about this in a little bit in the next page, but I'm going to talk about an example real quick. So this is one of the examples from the book. We have a scenario here. So we have Helen is opening her first saving account and is depositing $500. Suppose she decides on a bank that offers 6% annual interest to be calculated at the end of each year. So it's kind of like what I said earlier. She is putting in money, and this bank gives her a 6% of annual interest calculated at the end of each year. Okay, so if I were going to use my formula from earlier, I'm going to write it right here. Okay, what are some of the information that I can actually substitute in here? I don't know my A yet, so I'm going to keep my A there. P is your initial amount, which is 500 times 1 plus. Okay, R is your percentage. So we're getting 6%. So if we're getting 6%, we have to convert this to decimals first, which is 0.06 over K. How often is she getting this? She's getting this annually, right? So that means it's just a 1 at the bottom. and then K happens again, which is 1, and times T. Okay, one more time. This annual, that means K equals to 1. And this 6%, that helps for R. Okay, and then your 500 is P. And T, that's what they give us to find out our final answer. Okay, so for this question right here, I substitute all my information, and we're going to go ahead and go on from there. 500 plus 1 times 1 plus 0.06 to the T. That's the formula. And then they said, write tomato and determine the amount in the account at the end of 1 year and 5 years. So if I were gonna put in 500 times 1 plus 0.06 to the 1, and 500 times 1 plus 0.06 to the 5th degree. What do these give me? Okay, the first one, let's go to our calculator. I have 500 times 1 plus 0.06 to the first power, right? So it doesn't really matter. And it gives us 530. So this means when Helen puts in $500 in there, after a year, how much did she really gain from this? She got $30. Okay, so this is a 500 and a $30, and we add that together. This is really the interest that she gained, and this is her own money. So this bank is actually pretty good. After a year, she earns $30 from this 500. And let's go on to the other one. It's kind of the same thing, except I'm raising my parentheses to the 5th power, which is 669.11. Okay, we are stopping at 11, like at 1 and 1, because we are talking about dollar sign. We're talking about money, so we can't go any more further than cents. Okay, so after 5 years, she actually gained quite a lot. She gained almost like $170. Okay, so I hope this makes sense. From the formula, those of you who kind of want to understand where this formula comes from, remember P is your original amount, and if I'm multiplying to each of these, 1 is always the original amount. No matter what, you still have this original amount, and you're adding onto an interest. So this R over K is the interest. And then how many years it will take, we're just going to keep on multiplying that because it's an exponential type of function. So every year, however much they get, it matters for the following year. Okay. I was going to show you guys something like this real quick. This would help for your homework. So this one right here says, imagine that Helen finds a different bank that offers her 100% interest. Complete the table to calculate how much she would get in 1 year for each period of compounding if she starts with $1. Okay, this is too good to be true because if she put in $1, she would get back like 100% back of interest for the following year. And they just kind of want us to understand if they're compounding differently. Okay, so first off, if it's yearly, that means our compounding would be 1 because it only happens once a year. Okay, and then we put that 1 again right here and right here. Okay, and then semi-annually, that means it happens 2 times a year. Kind of like our school year, it's in 2 semesters. Okay, semi, it's a 2. So that's why it's down here and up here. Okay, if you remember, the K happens twice. Quarterly, quarter, there's 4 quarters in a dollar. So we got 4 and 4 here. Okay, and then we put it in the calculator. And this would be, let me just set it up. So I got 1, actually, do we have to? Let me see, this is, 1.25. Oops. So 1 times 1 plus 1 over 4, raise it to the 4. Okay, so it would be 2.44. Next one, 12 year, monthly is 12. So I'm gonna set up everything. So it'll be 1 plus 1 over times 1. And 12 would be all here. Okay, so this would be 12, and this would be 12. It'll be $2.61. Okay, so I guess if you kind of look at this, is it better to be compounded yearly or is it better to be compounded monthly? If it was me, I would want it to be compounded monthly because look at how much we really get. If it's yearly, if it only happens once a year, I only get $1 extra. But then if it's monthly, then I get $2.61, which is I gain $1.61. Okay, so let's continue from here. We got weekly. So I'm gonna kind of stop this formula column. I'm just gonna write down the K equal and the amount. Okay, so if it's weekly, how many weeks in a year? We have 52, right? And the amount here is 2.69. Daily is 365 in a year. We don't really count leap year. Okay, so 2.71. Hourly, 800. Oh, actually, hold up. How do we get hourly? If it's daily is 365, that means we're going to multiply this 365 with 24 because there's 24 hours in every day, right? So if I multiply that, that gives me 8,760, which we kind of get $2.72 his estimate. Okay, now every minute, I'm going to take my previous answer, and what would I multiply this to? 60, right? Every hour there's 60 minutes, so we have 525,600. And if you put it in a calculator, it also gives you around 2.72. If you go into more numbers, it would definitely be more than the previous one, but we're just gonna round it. And the last one, we multiply another 60 to it, and this is the amount that we have, 3 zeros. Okay, and we still get 2.72. Okay, so that's it for this lesson. Let me see if you want me to do one of your homework questions. I don't mind doing one of your homework questions for you. So if you think you got the hang of it, you can stop the video or you can pause and do the work and check my answers. Okay, let me do number 4. Okay, so it says an investing group has 50,000 to invest. They put the money in an account that has an annual interest rate of 6%, compounded monthly. Got this amount. How much money will the group have at the end of 10 years? Okay, so let's write down our formula. We got A equals P times 1 plus R over K to the KT. The only information that we have is P, which is 50,000, and we have a R, which is 0.06, okay, over K compounded monthly. So monthly is 12 at the bottom and also 12 up here. Okay, did they ask us to write the formula? Oh, you can just figure it out from here. And we have our 10. Okay, so I'm going to put everything back in pink. Have all of this information here. Okay, and we're actually ready to find out our final answer. So I'm going to go ahead and put it in here. We got 5,000 times 1 plus 0.06 over 12 to the 12 times, what was it? Was it 5? 12 times 10, which is, oops, 12 times, okay, I'm just going to put 120, okay, 12 times 10. So the amount would be 9,096.98. 9,096.98. This would be the amount. Okay, and that's it. So go ahead and finish the rest of this page. For my honors, you guys have an extra two extra questions. Okay, so please let me know if you have any more problems, and have a good day.